So far, in all of the examples that you've created or looked at, variables have been used in fairly simple ways. Well, we're going to take a look at another way to use variables called arrays. Arrays are a data structure which allows multiple values to be grouped together in an easily accessible method. If you can remember back to chapter 2, we talked about variables and how they can be thought of as containers sitting on a shelf. Well, to extend that analogy, if a variable is a single container, then think of an array as a subdivided set of drawers on a shelf. You can still access that space on the shelf, but rather than being a single container, there are different miniature containers at that space. An array is structured like so. Let's take a look. So I'm in the Arduino IDE, and there are 4 key elements to an array. You have the array data type. In this example, we're using int, much the same as we would another variable. We have array1, it could be called anything, it could be called Sydney, it doesn't have to have the word array in it, it's just a unique name in the same way that a variable has a unique name. It has the array index, just there, and then it has the array contents, which we have here inside of our curly brackets, and each element is separated by a comma, so there are 4 unique elements or pieces of data inside there, each of which is an int. Now, you can create different types of arrays. However, an array can only hold a single type of data. So if you declare an array as an int, then it can only hold integers, like the example there. Now, like variables, arrays can be declared first and defined later, which allows you to create an array with blank spots in it and add data to it later on in your program. The array name follows the same conventions as a standard variable. It must be unique, it is case sensitive, and has a scope, global or local. The index refers to the position of the array contents. When declaring an array, you can define the number of elements or places, if you wish, that you have in your array. And finally, the array contents is the data that is inside your array. So let's take a look at some examples of how you can declare and define arrays. So adding on from the example here, I've created 4 different types of arrays. We have array1, in which we've said that we have 4 elements to the array. And inside we have these 4 pieces of data, 11, 5, 4, and 9. Now we have array 2, in which we've left the index blank, so we're not explicitly telling it how many elements are in our array. But you can see that there's 9 elements here. In fact, we can add a 0 to there to 0 index it, or in fact, let's add a 10 to the end of there. Show the example a little better. So 1 through to 10. So there are 10 elements in this array, and once it goes through that, the compiler will automatically sort out how many elements are in there and populate that yourself. So you don't always have to define the number of elements in an array. A little bit more efficient. Now here we've created, in array 3, we've said that there are 10 elements in the array, and we've left off the contents. Now that is the same concept if we're declaring an integer, just a standard variable. We could go array, a sum value. And instead of letting it equal something, we're just declaring and defining it later on, where we just leave out the equal signs and the value, and instead just put that semicolon there to terminate the line. Well, in the same way, we've said we've left out the equal signs and the curly brackets in the contents, and it will populate an array with 10 blank spaces in it, which we can go and fill in later on. Now, arrays don't just have to be ints. Here we've got a char type array, character, where it uses the ASCII table and it creates character type elements, and the character is 8 bits or 1 byte of data. And we've said that there are 6 elements in the array. We have H, E, L, L, O. Now you'll notice that's only 5. We've left space because there is actually a terminating character in that array. So there are 6 elements to it. So arrays don't just have to be ints. Now to access an array, you use its name and the index number of the element that you wish to access. Something to keep in mind though is that as with many things in programming, arrays are 0 indexed. This means that the first element in an array is indexed as number 0, and the second element as index 1, and so on and so forth. Whilst it can definitely be a bit confusing at times, it makes a lot of sense once you start getting used to it. So let's take a look at another example. Let's say in void loop, I wish to access part of an array. Well, as with a standard variable, you don't have to use the data type again, you simply use the array name. So let's take array1. Then inside my square brackets, here is where I use the index to reference a particular element in the array. So if I say array1 0, that means I'm accessing its 0 index, so the very first element in the array, index number 0, which is 11. So array 1, element 0 would equal 11. Likewise, if it is index 1, that is the second space in the array, which is 5, 2 would be 4, and 3 would be 9. And you have 0, 1, 2, 3, which is 4 elements in total. A little bit confusing, as I said, but you do get used to it. Likewise, I can access, even though I've got the word hello there in my array, I can actually access each individual letter. So rather than taking a string, for example, and saying, all right, string some word equals hello, then I've only got access to the string as a whole without some extra string manipulation and data control. I can simply say, all right, I want to find out what the second letter is in this array, and I know that it's an E, or I could leave that blank and fill in another word later on and then break it apart in the same method, which is really, really cool. So a really handy use in arrays that you'll see later on is we can create a for loop. So we create a for loop, standard counting loop int I, and let's say I wanted to use array 2 for output pins, and I want pins 1 through to 10 to be output pins. Let's say while I is less than 10, I plus plus, a standard incrementing for loop. I could then use pin mode, array 2, and in my index, put the local variable I. And that's really, really cool. Anyway, we'll get to that in a second, and we'll take a look at a more holistic example. So I'll re-explain how that works in just a moment. So now that you know a bit about arrays and how they work, let's put them to good use in a practical example to make an LED sequencer. Using your knowledge of LEDs, wire up 8 LEDs to your Arduino board using whatever pins you choose. However, I've used pins 2 through to 9, so 8 LEDs all up, and we're going to make them do some cool things. So I've got my board here, fairly simple. I've got my LEDs with a resistor going to ground from them. So I'm using a high logic, or active high logic, I should say. And then I'm connecting my ground to my Arduino board and the pin outs directly to the LEDs. So when we apply a 5 volt signal to them, they're going to turn on, which is cool. So here's our sketch, and it's fairly straightforward. We've got an array here called LED array, and I'm going to use these for the pin outs to reference which LED I'm controlling. So the array contents are 2 sequentially through to 9, which corresponds to the pins. I'm using pins 2 through to 9. Then delay time, which I'm just using as a counter for how rapidly we want the LEDs to sequence. Then, as I mentioned before, inside setup, I'm using this for loop. I'm using pin mode with the array index as I, and I'm declaring them all as outputs. Now what this does, let's go through the basics of this, because it's a really good example of using arrays. So at first for this for loop, if you know from the previous chapter when we're talking about logic statements, we've created a variable and we've initialized I as 0. So the first time this runs, I is equal to 0. So what it says is pin mode LED array 0, which corresponds to the first element in our array, so 2. Now LED array 0 is equal to 2, so it would put a 2, or actually a 2 in place of that. And then it would define 2 as an output. Likewise, when that's finished, I will increment again to 1. Now LED array 1 is equal to the second element there, which is 3, so it would replace all of that with a 3. And so on and so forth until they're all done, which is really cool because instead of writing out pin mode output 8 times, which is really clunky and bulky, 4 lines, which well actually 2 lines of code and 2 spaces for our curly brackets, gets the same thing done. And it's really handy because if we want to increase the size of our LED array, we can simply add some more elements to it, change the boundings of our for loop, and then we can declare as many as we want, which is really cool. So that is our pin modes done. Now we've got 2 separate for loops here, really, really simple. All we're doing is we're going to turn the LEDs on in order until they're all on, then we're going to turn them off again in the same order. And we can play around with the exact animation really easily by altering the flow of our for loops. So the first for loop here, again, really standard counting. We're saying that for int I, which is initialized as 0, while I is less than or equal to 7, again, it could be, in fact, to make it easier, you could say while I is less than 8, going to accomplish the same thing. Increment I, standard counting, we're going to write LED array I, so we're referencing each pin and writing it I, which is going to be in order from element 0, 1, 2, 3, 4, 5, 6, 7, which is 8 elements all up, remember 0 indexing, which corresponds to 2, 3, 4, 5, 6, 7, 8, which is the LED pins. We're going to turn them all on and wait for delay time, which is equal to 150 milliseconds each time. So there's a time for them to step up and increment. Then when it's done that, we're going to turn them back off and wipe back down in the same way, using the exact same concept, but we're initializing I at 7, running it while I is greater than or equal to 0, and de-incrementing I each time, which is really cool. So let's go ahead and load this up to our board. Plug that guy in. Make sure we've got the right COM port selected, hit upload, and you can see it's actually already running. I had this program on there just a moment ago. You can see the LEDs turning on and off in order. Really, really handy. Now again, you could implement a different, slightly different animation. We'll just copy this, replace the for loop here, and then instead of turning it on, we're going to turn it off. Now what this will do is turn them all on and then all off, and do a linear wipe, which is really, really cool. Well, they're both still linear, but it goes in the same direction. So you can see that all turning on, then they start wiping off. Really cool. Arrays are really simple but really powerful tools. And they're really good, especially for controlling outputs where you might have a whole group of LEDs. Now 8 LEDs doesn't sound like much, but let's say you wanted to control a 64 or an 8x8 LED matrix. Well, you can use arrays, and rather than having to declare each pin by itself and the pin mode and accessing each one by cross-referencing which pin number you're going to, you simply create it as an array and access each element that you want. So row 1 could be elements 0 through to 7, then row 2 is elements 8 through to 15, row 3, 16, so on and so forth, and you have a really logical, easy to organize way of having all your pin modes and your pin outputs clumped together. Really, really cool stuff.